Hey guys, so this lesson is going to be about quadratic models. Last lesson we did the linear models, so I'm going to show you what the difference is and how we can tell if it is a quadratic model this time. Just at the top here, I put quadratic models have these characteristics. In a table of values, the second differences are equal, and I'll show you how to do that. The graph of a curve is called a parabola, and I'll show you the features of that. And the equation can be written in the form y equals ax squared plus bx plus c, where a does not equal 0. So it always has that x squared value, and that is the highest one. So the highest exponent on the equation is a 2, or on the variable of the equation is a 2, just like it is right here. Okay, linear, it didn't have an exponent, but in quadratics, it has that exponent, and it's a 2. Let's look at how we can identify quadratic models in the different ways, similar to how we did it in the linear models. Okay, so identifying quadratic models. Which models represent quadratic relations and justify your answers? So we're going to do the same thing as we did last time. For it to be quadratic, the second differences have to be the same. So basically what we did in the last lesson, we have to do that twice in this lesson, and I'll show you how that works. So let's look at A, and again, you just have to do it on those numbers that you would put on the vertical axis. So I'm not going to deal with the H's in this case. I'm going to do the P value. So we have 250, 238, 202, and 142. So let's find the first differences. And just looking at them, I can kind of tell they're not the same. So the first differences are not going to be the same. But 250 minus 238 is 12. So we just subtract them. 238 to 202. And don't be afraid to get your calculator out, which is what I'm going to do. Because I'm good, but I'm not that good, especially at this time of night. So that's 36. And the difference between 202 and 142 is 60. So they're definitely not the same. It's not a linear. Then what you need to do is the second differences. So all you're going to do is find out what are the differences between our first differences. So we'll subtract these. The difference between 12 and 36 is minus 24. And the difference between 36 and 60 is minus 24. Notice, yay, they're the same. Those second differences. So this is a quadratic model. Let's try B and we'll see what happens with that one. So same thing, I'm going to do 32, 48, 72, and 108. And I'm going to find those first differences. 32 minus 48. So it's minus 16. Minus 24. Minus 36. So they're not the same. So obviously it's not linear. Let's check out this difference. 16, the difference between 16 and 24 is 8. And the difference between 36 and 24 is 12. So they're not the same either. So I can say for this one, it's not quadratic. So that's part B. The second differences were not the same, not quadratic. Again, the graph is the easier one to do, so we'll do C and D. Notice C has the shape that goes up and then comes back down. This is a parabola, so if you're like, I don't know what it's going to look like if it's quadratic. It looks like a parabola. So it's either going to have this shape where it looks like a hill, or it's going to have this shape where it looks like a valley, or I like to call them smiles and frowns. But it's got to have that shape. So in C, it does have that shape. So yes, it's quadratic. D, you'll notice is a straight line. It looks like a linear. So we'll say for D, it's linear. So not quadratic. Not quadratic. D and E are formulas. Not D and E. E and F. Guys, I'm doing this a little bit late at night, so E and F. E is y equals x squared plus 7. And F was y equals 3x plus 2. Now notice in this one, it has a 2 there. That's our highest one. That's our highest exponent. And that's what I said had to be for it to be, it had to be quadratic. So this one is yes, it's a quadratic. But in this one, it doesn't have anything there. There's nothing there. The highest is 1. So this one looks more like that y equals mx plus b. So I'm going to say no. This is linear. And so those are the differences. So you can look at a table, find the second differences. You can look at the graph, see if it's got like the smile or the frown. And if it doesn't, then it's not a parabola, so it's not quadratic. Or look at the formula. If the formula or the equation has the highest exponent on its variable to be a 2, then yes, it is quadratic. If it's any other number, it is not quadratic. Let's go look at one more example on the next page. All right, so let's look at this example. We're going to fit a quadratic model to data. A fountain of sparks from a Canada Day rocket follows an arc in the air. This table shows the height of the sparks at various horizontal distances from the launching point. So they did 5, 10, 15, 20, 25, 30. So that's how far away from the point it was. Determine the equation of the parabola of best fit and determine the maximum of the regression. Why did I ask to do that? I don't want you guys to do that. But let's take a look at it. And I'll tell you what you can do with it. So A, I'm not really going to determine the parabola best fit, but let's look at the curve and what it does. So let's scratch this. Guys, I don't know what I was thinking when I picked this example. But, okay, you can do this. You can do this in Google Sheets. I think that's why I wanted this one, because I wanted to tell you. You can do this in Google Sheets, and you can graph it and find the line of best fit and whatnot. And you can do it just like we would have done in our statistics unit, or with the linear models. You put the data into the table and you'll graph it, and then you'll choose the regression. But I wanted to make note, when you do the regression or you find the trend line, and he says it in the video, I might post that video again just to remind you guys, or I'll tell you where to find that video again because it's in our lessons. You're going to pick not the linear one, you're going to pick the polynomial. It doesn't say quadratic in the list, but it does say polynomial. So if you choose polynomial, it will do that for you. But essentially what's going to happen, like I can just look at the numbers here. And it goes up to like 110. And they do 5, 10, 15, 20, 25, and 30. So if we were to graph them, 30 is at 100, so it's just below. 25 is at 109. This is a terrible graph, guys. I'm sorry. It goes 108, which is kind of the same. 97 down here. 75. This is a terrible graph, but anyways, you see it goes up and then it's going to come back down. So just based on looking at it's a quadratic. I'm going to step away for 1 second. I'm going to see if I can actually graph this and put the graph in here so you guys can see it. And we'll talk about the maximum of the regression curve, and I'll see if I can find that as well. So I'm going to pause it, but I will be right back. Hey guys, I'm back. I've inputted the graph that I got off Google Sheets. So I did it on the computer because I had a hard time getting the trend line on when I tried to use Sheets on my iPad. So I did it on the computer in Google Sheets. I graphed the data, and then I chose polynomial. When you choose polynomial, it tells you what degree you want to do it. So you can choose degree 2. So I'm just going to write that on here that I did polynomial trend line. Trend line. And I chose degree 2 because you can choose that. I'll try and take a picture of it later and input it into the lesson. But for right now, I just have it, I'll write it down there for you. But as you can see, I was able to graph it. I inputted the trend line on there, or the regression line, and I chose it to show the formula. So you can see in the formula here, they've given it, it's just kind of backwards to what I had originally said. So it puts the x squared at the end instead of at the front, but it's got an x squared right there. So they did give us a quadratic. Now let me look at the questions that I determine the equation of the parabola of best fit. So I actually did do that. Yay. And determine the maximum of the regression curve. What does it represent? So you can see here our maximum is around here. And it is approximately 112-ish. We could find that out a different way if we were like really accurate and could zoom in on it. But it's about 112. And then what does that actually represent for us? For us, this is a rocket going into the air, and you can clearly see it goes up and comes back down. So that would be our maximum height of our rocket. That's the highest it goes, and then it starts to come back down. So that is what that would represent. I hope this didn't confuse you guys. But there you have it. That's how we can do a quadratic model. I'll see you do the practice stuff. Ask me if you have any questions, and I'll point you to those videos, and I'll take a screenshot of where you change your trend line and stuff in Google Sheets. But I'll see you guys in the next lesson. Bye.